Hello, I am Sam Putnam, Deputy Director of Data and Analytics for the Human Rights Campaign, and I will be talking today about mid-level donors and using data science in the Civis platform to identify donors that we can upgrade into the mid-level donor program. The Human Rights Campaign is the nation's largest organization fighting for LGBTQ equality, and we have about 3 million members and supporters and a digital reach of about 9 million people across various digital platforms. And we have been fighting for LGBTQ equality for over 40 years. Our 2021 priorities are the Equality Act, which is an act that would provide consistent and explicit anti-discrimination protections for LGBTQ people. And also in 2021, we've seen the highest number of anti-transgender bills in history. And so we've been doing a lot of work to fight those efforts and providing a lot of data out to our campaigns and organizing and field teams for that. I always think it's great to discuss what the data team looks like for an organization. And so here's a grouping of the members of our team. We have Susan Payne, who's the director, myself. I've been with HRC for about 7 years and originally come from a direct response and analytics background, but have branched out to doing political work as well as fundraising work on the data side. And then we have a senior manager on our team who is responsible mainly for quality control and managing the fundraising database, which is Roy Solutions. We have a senior data engineer who's in charge of data integrations, data flow, and also builds some apps for us. We have a data manager who's responsible for building data sets and getting data out to those who really need it. And then we have a data analyst whose primary responsibility is reporting, analysis, and predictive analytics. Our data ecosystem is pretty robust. This is a chart showing all of the different data sources that we bring into the Civis platform. Roy, as I mentioned, is our fundraising database of record. We also bring in van data. Engaging Networks is our email platform. We have a volunteering platform called Community Hub. We have a variety of different outreach platforms like Mobile Commons, which is SMS text, and Hustle, which is peer-to-peer text. We can put in flat text files, so we do an append with Catalyst that we flow into the data warehouse. And then we've got a variety of other different data sources. Okay, so today I'm going to be talking about our mid-level donor program. And this is a program for people who give anywhere from $1,200 to just below $5,000. The primary means of giving to this program is monthly giving of $100 or more. There are some one-time donors as well that just make a lump $1,200 payment. To bring in new Federal Club donors, a big feeder for that program is our monthly donor program, which is called Partners. These can be people who give $10 to $20 per month, whatever the amount they're comfortable with. Another important feeder for Federal Club has been events. So we have dinners across the country, and we also have a national dinner, which is a very large event. And then HRC has a presence at Pride events, hundreds across the country every year. And then to a lesser extent, we use direct response, web and email, direct mail, and telemarketing to bring in new Federal Club members. So the challenge for us is, in the context of the pandemic, the Pride and the dinner events were just not available for us. I mean, we're just not holding those events. There weren't Pride events, and we had to suspend dinner events. And looking at the source of new Federal Club donors, you can see it's a big chunk of the pie is the blue events, which are kind of event related. And so the trick is, how are we going to get new Federal Club people to keep the program healthy in this context. So we really look toward data science and the Civis platform as the solution for identifying potential new Federal Club donors, and decided to do predictive analytics models, one for predicting of our partners who would be likely to upgrade into Federal Club, and then for our general members who would be likely to upgrade into Federal Club. And looking back at the data ecosystem with all that rich data, which includes like voting history, donation history, demographic information from third parties, engagement information in terms of how engaged is someone with the organization in terms of are they responding to hustles, or are they opted into our email platform? Have they volunteered in the van? We can use all of that data in the Civis platform in a way that we couldn't before, when we were just using essentially data that's in the fundraising database. We kind of missed a whole side of the data, which would be more robust data about all the level of engagement that a person has with us. So for the Partners to Federal Club model, I was saying that the past way that we would try to identify people to upgrade from our monthly donor program into our Federal Club program was really based on kind of descriptive statistics about partners that had done that in the past. So the dollar level that they were at, we might choose people who are $20 or more, or they'd been on the file for X number of years, and so forth. But we really wanted to take a more scientific approach to building the select of who would be likely to upgrade into the Federal Club. The good news is that the training set to build this model was relatively easy to define, because we have a long history of inviting partners to upgrade. And so we had clear yes/no responses to these invites. So we decided to do logistic regression and used SQL to build a base data set. And then within Python, using pandas and scikit, we built the model within the Civis platform. So some of the key variables from the model that we created that were helping predict who would upgrade were within the partner program, had people upgraded. So if we'd seen a clear pattern of people going from 10 to 15 or 15 to 20, this is a really good predictor. And then we had some wealth indicators from a third party that were predictive of whether somebody would upgrade. And then interestingly enough, if somebody given a gift outside of their $10 or $20 per month gift that they'd set up, for instance, they're doing $10 a month and then they decide to give a $50 one-time gift above and beyond that, that was a good predictor. And then length of time on our file, length of time as a partner, and then some demographics, including age and household income. And on the right side is an ROC curve. And if you're into model building, this can be one of the good ways of assessing and evaluating how a model is going to perform. And generally speaking, a curve that is off of this red line is better. So the further off that red line, the blue line is, the better the model does. And you ideally want it to be flat against the left and the top side as much as possible. And so this model, with an ROC curve, you're also looking at the area under that blue line, which is called the area under the curve. And for this model, the area under the curve was 0.741. And usually in assessing a model like this, an area under the curve of between 0.7 and 0.8 is considered good. Between 0.8 and 0.9 is excellent. And above 0.9 would be just an outstanding model. So we felt like this model would serve us well. It performed well enough to be predictive. If this curve had been, for instance, pretty close to this red line and just flat, it would not be very predictive of giving. So we felt like this model is performing pretty well for us to use. For the general members to Federal Club model, the training set was much more challenging because we didn't have a consistent history of inviting just general members to upgrade into the Federal Club program. So the yes part was easy to define. That was just people who gave to the Federal Club. But the no was more difficult to find. And we ended up kind of defining it as people who could have given to the Federal Club at some point in their membership with HRC, but hadn't done it. And so we wanted to make sure that if the people who had upgraded to Federal Club, for instance, had all given prior to their upgrade within 5 years, that the no group would be within a similar sort of time frame. And so we ended up building kind of a stratified group for the no group that matched as closely as we could, in general, the longevity of the donors who were in the yes group, and also the donor history. And some of the thinking there was that if, for instance, all of the people who had upgraded to Federal Club had given 2 or more gifts, if we were pulling in people for the no group who had only given 1 gift, then we might not be having a strictly comparable group to the yes group. So we did a lot of work in making sure that the 2 groups were comparable enough that we felt like we could get a good model out of this. And at one point, we'd even considered whether we should do a look-like model instead of a logistic regression model. But in the end, we decided to do a logistic regression model. And again, we used SQL to build a data set and Python to actually build the model. The key variables for the general member to Federal Club model were giving history, and that includes total giving, giving within the last 24 months, engagement, so the contactability of the person, were they opted into our email, were they engaged with us on SMS, and so forth. And also, the key was self-provided data. So we have surveys where our members and supporters can provide gender identity, orientation, and basic demographic information about themselves. And we found that people who provide that information are much more likely to upgrade into Federal Club. And we looked at demographics as well, household income and age. Age was interesting because the model would punish you the younger you were and reward you the older you were. And we also looked at political activity, which included PAC and general political giving, as well as voting history. When we were evaluating the model for the general to Federal Club, the curve that I mentioned before was extremely strong. It was above 0.9 area under the curve, which is just an outstanding model. And we were even a little skeptical that it looked so great. It was one of the best ROC curves I've ever seen. So one of the things that we did in evaluating the model was we just took a group of people who had contributed within a specific time frame and scored them, and then looked at how many of them upgraded and how many didn't, just as a way of gut checking the model's performance. And we found that it really was very predictive. And one of the other things that we did, in addition to using an ROC curve to evaluate the model, is we did box plots, which I think these are really interesting to look at. And unfortunately, you can't see my screen, but what the box plots do is they plot out the predicted probability that someone will do the behavior. And then you can have one box plot for people who did not do the behavior and one for who did, and you can see where they cluster. So in this one, under the did not upgrade, you can see that the clustering of the individuals is down toward the lower scores. And for the did upgrade, there's a strong clustering of people at the highest scores. The models were incredibly effective. we saw 130% increase in our federal club direct response campaign compared to the previous year. It was the best campaign we've ever had, and the bulk of the new federal club donors that we got were identified by the two models. And so the takeaways are, before we had Civis as a platform and we were bringing all this data together, we would have just relied on the fundraising data and kind of missed the full scope of all of the data that can be useful in identifying who the best prospects are for something like this. And, while we had good techniques for selecting people into campaigns, data science really helped inform who the most likely donors would be and improve the results greatly. And with that, I think that was the end of my presentation.
Well, Sam, I think what we can gather from this is that data science and data in general, knowing how to use it and how to combine it is really what will drive kind of next steps and ensure that you're getting the most out of the folks that you engage with, right? So I want to take a little bit of a step back because you've often talked about the team. And for organizations that are hearing you and hearing the fantastic results that you have, can you talk a little bit about the team, how it's structured, and how you're able to come to the decisions that you do?
Sure. Yeah. Our team is really structured in a way where, we try to give people key areas that they focus on, but also give them areas where they can expand into. So while our data analyst does most of the reporting analysis and predictive analytics, we also give our data manager opportunities to do analyses and reporting as well. And our senior data engineer, who mainly works with data integration and data flow, will also build reports and help build data sets for analyses. So we have it structured where there's just an element of daily production that needs to happen, where the senior manager who's doing quality control and the fundraising database management will work with the data manager who's building the data sets to get the data out. And then the data engineers kind of making sure that all of the data is flowing correctly, that all the workflows are happening, that the data integrity is there. And then the data analyst is mainly working with data sets that are built by either the data manager or the engineer.
Mm-hmm. Thank you for that, because I can imagine some attendees may be thinking, we'd love to be able to replicate what has been done, and what's the team behind that, and how do they have kind of the brain trust to think about data in this way, and then have the bandwidth to execute on it. So that was, really helpful. Sam, thank you for joining us today. Thank you for your time and your expertise. Like I said, we will be sharing out these slides so that you can have the full experience of all of the data. But Sam, thanks again for your time today.
Okay, thank you.